In this video, we will be going over determining rate laws by experiment data. So in this reaction, we have dichromate reacting with nitrous acid and 5H plus ions to form our products. So we have 4 experiments done, and we will manipulate the concentrations of all 3 of our reactants. Then we are given the initial rate of reaction for each experiment. Remember that rate laws can only be determined experimentally. So to answer question A, what is the order of reaction with respect to Cr2O72-, our dichromate ion? What we need to do is we need to look at when the other 2 reactants, their concentrations are held constant. So what we will do is we will look at experiments 3 and 4. The reason for this is that in experiments 3 and 4, the concentration of our other 2 reactants are held constant. While these are held constant, the concentration of our dichromate changes. In other words, since the other 2 reactants are held constant, if the concentration of our dichromate changes, that is the only thing responsible for affecting the rate of reaction. What we will do now is we will take a look at how changing our concentration changes the rate. So if we take our initial concentration from experiment 3, which is 0.5, divided by the initial concentration experiment 4, which is 0.25, we're going to compare that with the initial rates of reaction, which are 8.4 times 10 to the negative 3 and 2.1 times 10 to the negative 3. When we solve for this, we get 2 to the power of n equals 4. In other words, n here is equal to 2. So this is second order. Now let's look at HNO2. For HNO2, we will look at reactions 1 and 4. The reasons for that is that if we look at reactions 1 and 4, we see that our dichromate and H+ are held constant, but our nitrous acid concentration changes. So what we will do here is something similar. We will take our 0.48 divided by 0.24 equals 2.1 times 10 to the negative 3 and 2.1 times 10 to the negative 3. We could see that here, this simplifies to 2 to the power of n equals 1. So in this case, n equals 0, so this is 0th order. In other words, no matter how much we change the concentration, the rate of reaction will not change. Lastly, to figure out the rate of reaction for our H+, we will look at experiments 2 and 4. Notice how the other 2 variables are held constant. When we simplify this, we see that our n is equal to 1. In other words, this is first order. In other words, if we double our concentration, the rate will double. If we triple our concentration, the rate will triple. So to write the overall rate law, we just combine all of the data we've gathered. So the rate is equal to, we always write our rate law lowercase k, and then the concentration of our dichromate to the power of 2 because it's second order. Then we will omit our HNO2 because it is to the power of 0. But it doesn't hurt if you write HNO2 to the power of 0, that as well. But if you do not write it, that is okay because this will simplify to 1 because anything to the power of 0 is 1. And then finally, we will have our H plus to the power of 1. Now, for the final question, part E, calculate the value of K with units. We're going to use our experiment 1 data. So all we have to do is plug in numbers for the rate law we got in part D. So I'm going to write the rate 2.1 times 10 to the negative 3 molarity per second equals K times the concentration of dichromate, which is 0.25 molarity, the concentration of nitrous acid, 0.48 molarity. Whoops, I forgot the squared here on dichromate, so I'm going to put the 2 up there. And then finally, my concentration of H+, which is 0.1 molarity to the power of 1. Now here, this term will just cancel out to 1. Now if I simplify this, I will get 0.34 molarity per second times 1 over molarity cubed equals K, which simplifies to 0.34 and 1 over molarity squared second equals